This video is for P9 Electromagnetism. This lesson introduces electromagnetism as students explore electric current producing a magnetic field. Students build and test their own electromagnet, gaining understanding of how electromagnets work and how to modify the magnetic fields they produce. Exploration 1 allows students to create an electromagnet and then explore variables as they change the strength by adding more layers of coiled wire around the nail. This produces a linear increase in the number of paper clips picked up by the electromagnet. Students are given a handout which has concise directions on how to create an electromagnet, what their setup should look like, and reminds them to write down their data in the form of the number of paper clips on their worksheet. The first test has students coiling one layer of wire around the nail. It's especially important that students are reminded not to keep their electromagnet connected when they are not testing or picking up paper clips. This will drain the battery. One layer of coiled wire around the nail picks up approximately 5 paper clips. 2 layers of coils pick up approximately 9 paper clips. 3 coils of wire picks up approximately 15 paper clips. A direction card is provided in the bag for Exploration 2. These are left very open-ended so that students are able to explore with battery number on their own. When students test the number of batteries, they will naturally create situations where batteries are in series or parallel. The nature of the battery holders connecting without additional alligator clips is significant when students don't have prior knowledge in circuits. Additional batteries in series or in parallel will create a stronger electromagnet. Students can place battery holders in series by connecting them as such. As seen here, we have positive terminal, negative terminal, positive terminal, negative terminal. Students are not able to connect negative to negative. It's physically impossible with these battery holders. So students will have to figure out how to connect them, and whether you use the term series or parallel is up to you based on the prior knowledge of your students. Students will then connect the alligator clips to the positive and negative. So the first positive and the last negative. We don't need any connections made in between. When a third battery is added, again, they won't be able to connect negative to negative. So students will have to connect positive and negative, and they should slide their alligator clip to the last terminal. So we have positive and negative connected here. When students are snapping together their battery holders, some may naturally create them in parallel. Here, students can connect the positive and the negative of the first battery holder, the only ones that are available. So these would be 3 batteries in parallel. A second part of Exploration 2 is testing core material of the electromagnet. Students are provided with a general direction card asking them to compare the strength of the original electromagnet to the 3 electromagnets that they'll create with different core materials. Core materials include a large wrought iron nail, an aluminum nail, and a golf pencil. Because the golf pencil and aluminum nail are non-ferromagnetic materials, they will not create an electromagnet. No paper clips will be able to be picked up. The large wrought iron nail is significantly longer than the original nail, and the diameter changes. This will definitely affect the strength of the electromagnet, but is used to show a dramatic effect of a larger ferromagnetic material in an electromagnet and how it can pick up almost all 25, if not more, of the paper clips.